Some experts believe that in the next 3 years, the world as you know it could undergo a fundamental transformation. This isn't a distant, abstract future. It is a potential tidal wave of change that some models suggest could arrive in the next 36 months, driven by a series of wild, almost unbelievable predictions about quantum computing that have even the world's top scientists deeply concerned. This is no longer just science fiction. For many, it's becoming the new reality. We are standing at the precipice of a new frontier, one that promises the potential for a world that is better, faster, safer, and most critically, exponentially more powerful. To understand the magnitude of this shift, consider one of our last great transitions, the move from horses to cars. We often romanticize progress, but the truth is rarely so simple. That transition wasn't universally better, at least not at first. Cars were mechanically complex, temperamental, and far more difficult to operate than a horse. They were astronomically more expensive, accessible only to the wealthy elite, and with their unprecedented speeds, they were tragically less safe. This pattern of disruption of initial chaos, expense, and danger has defined nearly every major technological leap in human history, from the printing press to the internet. But the quantum revolution could be different. It's not seen as a gradual change. It's a cliff. Experts are calling it the quantum cliff, a sudden and dramatic point of no return. The fundamental transformation of cryptography, of national security, of medicine, and of computing itself isn't a gentle slope. It is a sheer drop, and some predict it could arrive as early as 2025. What lies at the bottom is a world we are only now beginning to imagine. Even the architects of our modern digital world, the pioneers of the internet, the visionaries behind cloud computing, are admitting they have never seen anything quite like this. The velocity of change is staggering. By some estimates, the pace of development is anywhere from 40 to 50 years ahead of what established roadmaps once predicted. But the public story is only half the picture. The real story, the one that might explain this impossible acceleration, is what insiders are reportedly witnessing behind the closed doors of the world's most advanced laboratories. A distinct three-step pattern appears to be emerging, a formula that could be unlocking this future right now. First, what was long considered the primary obstacle to quantum power appears to be crumbling. For decades, scaling a quantum computer was a process of guesswork and brute force. But now, researchers are beginning to crack the code on fundamental scaling laws and, crucially, on error correction. Quantum systems are exquisitely sensitive, prone to errors from the slightest environmental disturbance. Overcoming this has been the Holy Grail. With these breakthroughs, it's now possible to calculate with mathematical precision how much computing power and data are required to achieve the next level of quantum capability. Building these powerful computational machines is transitioning from an art into a science. Second, a deceptively simple discovery appears to have yielded an exponential leap in power. Researchers have found that merely allowing quantum systems to operate undisturbed for longer periods, a metric experts call coherence time, and applying new, refined error correction codes, can result in a massive, almost unbelievable improvement in performance. We are not talking about a 10 or 20% increase. We are talking about orders of magnitude, a jump in capability so vast it's difficult to comprehend. It's like discovering that leaving a car engine running overnight could somehow transform it into a rocket. Third, and this may be the foundational pillar upon which this entire revolution is being built, is the breakthrough in hardware stability. This is the moment theory began turning into reality, when Nobel Prize winners John Clark, Michel Devoret, and John Martinis demonstrated that quantum behavior, the strange and wonderful rules that govern the subatomic world, could occur in macroscopic, human-made circuits. They forged a final critical link. They proved that entire electrical circuits, visible to the naked eye, could behave as single, cohesive quantum objects. This monumental achievement bridged the chasm between abstract quantum theory and practical engineering. It helped transform the dream of a quantum computer into a tangible, achievable blueprint, paving the way for the potentially earth-shattering advances we are witnessing right now. Let's return to the timeline. Many experts are pointing to 2025. They believe this could be the year it all begins to change. This is projected to be the year that quantum supremacy, the point where a quantum computer can perform a task no classical computer could ever complete, evolves into quantum utility. We are about to cross what experts call the practical application threshold. Imagine a world where one day, the most complex problems in science and industry are functionally unsolvable, and the very next day, a new form of computing begins to solve them. These are seen as the first real-world applications poised to reshape our world. We are already witnessing the dawn of this era. In medicine, quantum computers are poised to revolutionize drug discovery by simulating molecular interactions at a true quantum level, a feat that is utterly impossible for even the most powerful classical supercomputers. The promise is that this will slash the time it takes to identify promising new drugs, from life-saving antibiotics to revolutionary cancer treatments, and eliminate billions of dollars wasted on experimental failures. In the quest for clean energy, quantum computing shows promise in accelerating the development of nuclear fusion. By performing advanced simulations of plasma behavior inside a reactor, it may allow scientists to perfect designs and achieve stable fusion reactions with a fraction of the physical prototypes, bringing the dream of limitless, zero-carbon energy closer than ever. In material science, the goal is for these machines to design novel materials from the atom up, simulating properties with perfect accuracy to invent next-generation batteries, room-temperature superconductors, and impossibly strong, lightweight composites. And in the field of artificial intelligence, many believe quantum computing is on the verge of supercharging AI itself, dramatically accelerating the training of complex machine learning models to create intelligence that is beyond our current imagination. Now let's look ahead to 2026. This is projected by some to be the year of quantum infrastructure consolidation. As the technology proves its worth, we can expect the titans of the tech industry to begin to move, absorbing the small, research-intensive startups that have quietly laid the groundwork. Google's recent acquisition of Atlantic Quantum, a pioneering MIT-founded startup developing advanced superconducting quantum hardware, is seen by many as the first tremor of this coming earthquake. The most important companies in the quantum space today are not household names. They are small, highly specialized firms building the critical, foundational layers of the ecosystem. They are crafting the picks and shovels for the new gold rush. Just as NVIDIA became the indispensable engine of the AI boom, by supplying the powerful hardware nobody else could build, a new class of quantum infrastructure companies is now positioning itself. They are the ones making the error correction software, the cryogenic control systems, the photonic processors. They are quietly positioning themselves to become the indispensable, non-negotiable engine of the quantum economy. The roadmap now takes us to 2027, and this, according to some forecasts, is where the predictable ends and the truly wild begins. Many analysts suggest that 2027 could be the year of widespread quantum advantage, the moment quantum computers are not just useful for specific problems, but begin outperforming classical computers across multiple critical domains. To grasp the scale of this leap, consider a recent demonstration. A Google quantum chip reportedly performed a complex calculation in under 5 minutes. To complete that same task, it was estimated that one of the world's fastest classical supercomputers would have needed 10 septillion years. That is a number so large it's meaningless. It's a 1 followed by 25 zeros. It is a span of time vastly longer than the entire age of our known universe. This single result was so reality-bending that it reportedly led Hartmut Neven, the director of Google's Quantum AI Lab, to suggest that it offers compelling evidence for the many worlds interpretation of quantum mechanics, the almost mystical idea that the computation may have been performed by harnessing the power of parallel universes. But alongside this incredible promise lurks a threat so profound that it has even the most optimistic experts terrified. This is what insiders refer to as the quantum threat to global security. The raw power of quantum computing represents what many consider to be an unprecedented existential danger to the encryption systems that safeguard nearly all of the world's digital information. Your bank account, your private emails, the global financial markets, your health records, the command and control systems for our national defense. The security of all of these relies on a type of lock that powerful quantum computers, in theory, are perfectly designed to pick. In a world with fault-tolerant quantum computers, it's feared that the encryption protecting our civilization could be shattered in a matter of hours or even minutes. Cybersecurity experts have a name for this future inflection point: Q-Day. It is the day a sufficiently powerful quantum computer goes online and can crack our most widely used encryption standards. Experts warn that on Q-Day, the very concept of digital trust could evaporate. Everything we have ever sent digitally could, in theory, become vulnerable. Every email, every text message, every Bitcoin wallet, every hospital record, every command sent to a power station. It is widely believed that foreign intelligence services, rogue nation-states, and sophisticated criminal organizations are not waiting for Q-Day to arrive. They are engaged in a massive, covert operation right now, harvesting vast amounts of encrypted data and storing it, waiting for the day they can decrypt it all. It's a digital time bomb. The consequences are almost too profound to fully grasp. If we fail to transition to new, quantum-resistant forms of encryption, the integrity of communication that underpins modern society could disintegrate nearly overnight. The reason we haven't already made this switch is simple. Until recently, most didn't believe fault-tolerant quantum computers would exist for another decade. But the massive, unexpected advancements of the last few years appear to have shattered that timeline, forcing the entire industry into a desperate race to invent and deploy new post-quantum cryptography standards before it's too late. So, where does this leave us, standing on the edge of this new world? The narrative of the next 3 years will likely not be written by observers. It will be shaped by those who act first. Many analysts predict that the immense value of this new era will accrue to the companies that control the foundational layers, the infrastructure, the hardware, and the algorithms that will power this new paradigm. It's believed the truly historic gains may come from the under-the-radar companies, the ones building the core of this revolution before the broader market even realizes the game has changed. And given the breathtaking speed of quantum innovation, it may not take long for the world to catch on. The future will likely be owned by those who are brave enough to be first movers, the leaders and organizations willing to adapt, to pivot, and to build a future that embraces the power of quantum technology. This is arguably the single biggest shift in computational capability since the invention of the computer itself. And we are all about to live through it. The quantum age isn't just coming anymore. Many would argue it is here. The only question is, will you be ready? The quantum future is arriving faster than anyone predicted. To stay ahead of the curve and understand how these changes will impact your world, make sure to subscribe and click the bell for notifications. We'll be tracking every step of this revolution. What are your biggest questions or concerns about the quantum age? Let us know your thoughts in the comments below.